welcome back to Bleed Electrical. This is course on Energy Management and Audit, and I'm Triveli Naidu from the Department of Electrical Engineering at St. Vincent Pallotti College of Engineering and Technology, Nagpur. In the previous video, I have already spoken about the procedure to be carried out in order to find out the material balance. And then we have also discussed two examples, two numericals. Now in this video, we will be continuing with the same topic and taking some more examples on this topic. We'll be taking two more numericals on this topic. So let's get started. So example of gas composition. In the carbonation of a soft drink, the total quantity of carbon dioxide required is the equivalent of 3 volumes of gas to 1 volume of water at 0 degrees centigrade and atmospheric pressure. Calculate the mass fraction and the mole fraction of carbon dioxide in the drink, ignoring all components other than CO2 and water. So this is the question given to us. This is an example of gas and water. Okay, this is the gas composition. So you have a soft drink over here. See, in soft drink there are so many components present. Okay, sugar and salt is also present, but we are not considering, we are ignoring all the other components over here. We just have to consider carbon dioxide and water and then calculate. Okay, so it is given to us how much volume of 3 volumes of gas to 1 volume of water. So this is how the quantities are expressed. So let's find out the solution to this. Now let us take the basis. We have to firstly take the basis. So basis as 1 meter cube of water. So what is the conversion factor for 1 meter cube of water? It is 1000 kg, or we can say 1000 liters. Okay, so that is, you get the 1 meter cube of water as basis. Now volume of carbon dioxide added. See, if I have taken 1 meter cube of water, then 3 volumes of carbon dioxide was mentioned to us. So it is 3 meter cube. Now, from the gas equation, we have PV is equal to nRT. P is known, V is known, R is known, and T is known. Are we knowing N? No. So we have to find out the value of number of moles. So this is how you find out the number of moles. Okay, calculate the number of moles, substituting rest of the values. Okay, and then you get the molecular weight of carbon dioxide. What is the molecular weight of carbon dioxide? CO2. Carbon dioxide, one molecule of carbon plus O2 means 2 molecules of oxygen. So you find out the value of carbon with the combination of oxygen and write down the molecular weight over here. Okay, so weight of carbon dioxide added would be the multiplication simply of the molecular weight, because you what are you finding out? Weight of carbon dioxide and the number of moles that you have calculated from here. Once you multiply these two things, you get what? The weight of carbon dioxide. Then we need to find out the mass fraction of carbon dioxide in the drink. Okay, so now you have got the weight. You need to calculate the mass fraction of carbon dioxide. So I'll take the carbon dioxide divided by 1000 plus the weight of the carbon dioxide. So you get the answer. And then the second part of the question was mole fraction of carbon dioxide in the drink. So you find out the mole fraction of carbon dioxide in the drink. So these values are actually calculated. I just wanted you to calculate it and then tell you the answer. So I have mentioned it over here. I'll be showing it to you. Okay. So simply calculate this and you get the answer. So this is what you do. Okay, we are concentrating only on carbon dioxide when mixed in water and what all things happen and how to calculate it. So let's see the solution. So 1 meter cube of water is 1000 kg. So volume of carbon dioxide will be 3 meter cube from the question. Then from the gas equation, what did we find out? The value of N, because P was 1 atmosphere, volume was 3 meter cube. Then N, I don't know. The gas constant was 0.08206 into, this is 1 Kelvin, so 273, 1 degree Celsius, so 273 Kelvin. So now N becomes 0.134 mole. So molecular weight of carbon dioxide, CO2, is actually 44. You can use this. So weight of carbon dioxide becomes the number of moles multiplied by molecular weight of carbon dioxide. So that is how you get the weight of carbon dioxide, that is 5.9 kg per 1000 kgs of water. Then we were supposed to find out, this was the basic things that we have calculated. Now we are coming to the question. We were asked mass fraction of carbon dioxide in the drink. So how to find it out? The weight of carbon dioxide divided by weight of water, that is 1000 kg, plus weight of carbon dioxide again. So you get this value. So this is the value. Okay, then secondly, what was asked of you? So mole fraction of carbon dioxide in the drink. So now we are supposed to find out the mole fraction. So I have to take the number of mole. What did you calculate? 0.134. So 0.134 divided by this molecular weight. So this weight of the water divided by 18, because this is the molecule, this is the number of moles you have to write. Okay, you don't know the number of moles of water, so I'll have to take number of moles of water. How would I calculate? 1000 means the weight of water divided by the molecular weight of water is H2O. So H and two molecules of H, one molecule of oxygen, that becomes 18. 2 plus 16 है ना. So now it becomes 1000 divided by 18. This is number of moles. Okay, number of moles of water plus number of moles of carbon dioxide that we have found over here, 0.134. So this is how you calculate the mole fraction of carbon dioxide, and it is 2.41 into 10 to the power minus 3. So I think you have understood this. This is how you calculate the carbonation of carbon dioxide in water. Okay, so this is how you calculate. This is the solution. Now let's take example on a mixture. This was we spoke about gas and water. Now let us take an example of a mixture. So let us take methanol and water mixture. So let us take this example. Two methanol water mixtures are contained in a separate flask. The first mixture contains 40% weight methanol and the second mixture contains 70% weight methanol. If 200% gram of first mixture is combined with 150% gram of second mixture, what are the mass and composition of the product? So let's see. Now solution. Now we have flask number 1. What is the weight of methanol given to you? 0. So that is 40%. So I am taking 1 as my reference or basis. So mass of methanol, M stands for methanol. It is 0.4 because 40%. No. And out of 100, if I take out 40, so remaining will be the mass of water. So what will be the mass of water? 0.6, that is 60% water, means 40% methanol, 60% water. Although it was not given to us in the question, but we can calculate it by 100 minus this term, that is 40% of methanol. So that is how you get the weight of water. So this is mass of methanol, mass of water. And in another flask you had how much methanol? 70% methanol. So remaining is 30% water. So 0.7 is the mass for methanol and 0.3 is the mass for water. Now what is told to you is you are taking 200 gram from flask 1 and you are taking 150 gram from flask 2 percentage. Okay, and you're giving it to the combination, you're making a combination out of these two things and you get a final product. Okay, so assuming steady state condition and no chemical reaction, we can simply write this is a material balance equation, so input should be equal to output. Yeah, so let me first calculate what is the input of this. Let me first calculate what is the input of this. Now input is equal to what? How much percentage is given to me? 40%. So 0.4 multiplied by how much is the value of this 40%? It is 200. Okay, so 200 is the gram. So 0.4 into 200 plus 0.7. What is the weight of water? Weight of water for this? Weight of water for 150. So no, we'll be firstly talking about methanol. Okay, this is the input only for methanol. So MTM, M stands for methanol. So methanol from here is 0.4. 0.4 of 200 grams. So 0.4 into 200 grams. And then methanol from here is 0.7. So 0.7 of how much grams? 150 grams. So we find out the value of methanol. That is 185 grams is equal to This is the value. Okay, so this is the output that you get in the combination for methanol. Now I'm interested in water. What is the input for water? It is 0.6. How much gram is that? 200 grams. So 0.6 into 200 gram plus how much water is over here in the flask 2? It is 0.3. So 0.3 into how much gram is mentioned over here? 150 gram. So you get this much gram as output. So now this product will be containing 185 grams of what? Methanol and 165 grams of what? Water. So total will be how much? The mass of methanol plus mass of water, that is 185 plus 165, that is 350 grams. So methanol, if I calculate the percentage that it is taking, is 52.86 percentage by mass, and water is equal to this plus sign. It is not the plus sign, it is equal to sign. So water is equal to 47.14 percentage by mass. This is what you get the solution. So I hope this question was cleared. So this is how you calculated the solution for the combination of methanol and water in two different flasks, and once you carry it out. Now what this chart is known as? Once you got the question, you prepared a chart from this. Okay, this is nothing but the process flow chart that we have made. And finally, what we have done over here, writing the material balance equation. So this is the entire procedure of conducting the material balance. Okay, firstly you have to define the basis. You have given the basis. Secondly, you draw the process flow chart, and thirdly you write the material balance equation. So this is all done in the solution. So that's all for this video. In the upcoming videos, we'll be talking on energy balance. Thank you.